Welcome back to another deep dive from the Rooster Pod log, where we help you really master PySpark.
Yeah.
You've been wrestling with how to make your applications really shine,
Mm.
and we're here to tag team with you on two powerhouse techniques, checkpointing and caching.
These are like essential for any PySpark developer looking to, you know, take their game to the championship level.
Okay, so you're in the middle of this massive Spark job,
Right.
maybe a Royal Rumble with tons of transformations and actions happening.
Yeah.
Suddenly a node in your cluster just crashes.
Oh.
Oh, right.
Yeah.
That's where checkpointing steps into the ring.
That's right. It's like your ultimate insurance policy.
Yeah.
You're hitting that save button in a video game. You're taking these snapshots of your data's progress and storing them safely. So if a node goes down, you don't have to start from level 1. You pick up right where you left off.
Ooh, nice.
Yeah.
Talk about a painful pin,
Right.
like having to start all over.
Oh.
But it's not just about recovering from failures, though. It also helps streamline the whole operation.
Exactly.
Yeah.
Spark keeps a very detailed record, like a lineage graph of all the moves and transformations you apply to your data.
Mm-hmm.
As things get complex, that lineage can get messy and slow you down.
Like a steel cage match with way too many wrestlers.
Exactly.
So checkpointing really helps cut through the chaos.
Yep.
Makes it cleaner and easier for Spark to manage.
It really does.
We've got two main ways to checkpoint: reliable and local.
Right.
So reliable checkpointing is like locking your championship belt in a vault,
Yeah.
using HDFS or S3 for security.
Yes.
Local checkpointing is more like stashing it under the ring faster, but riskier.
Exactly. If fault tolerance is your top priority, reliable checkpointing is your go-to.
Mm.
It's a bit slower because of the disk writes involved, but you get that peace of mind. Local checkpointing is usually used when speed is king, like in Spark streaming, where, the data might not be as critical.
Got it. So when do we absolutely need to bring in the checkpointing cavalry?
Anytime you're dealing with long, complex pipelines, picture a grueling Ironman match.
Oh, yeah.
Iterative algorithms, especially in machine learning, definitely benefit. And, of course, for Spark Stream to work its continuous magic,
Yeah.
checkpointing is essential for maintaining state.
But hold on, don't go hitting the checkpoint button every 2 seconds.
Oh,
When would it be overkill?
simple, short jobs or like a quick one-on-one match.
Right.
Checkpointing is probably overkill.
Makes sense.
And if you're working with limited disk space, you'll want to be smart about how often you checkpoint.
Yeah.
It's about choosing the right move for this situation.
Okay, before we move on, how does checkpointing compare to caching and persistence? Are they all part of the same team?
They are, but each plays a different role. Caching gives you a quick burst of speed, storing data in memory for rapid access during a specific match. Persistence is similar, but offers more control over where the data is stored. Memory disk, or a combination. Checkpointing, though, is the real champion for long-term resilience. It breaks free from that huge lineage graph, making your applications more fault-tolerant and efficient in the long run.
Now let's shift gears and talk about pure speed.
Okay.
We're talking about making your Spark jobs feel like they're powered by rocket fuel.
Right.
That's caching.
Yes, caching is all about strategically storing intermediate results.
Mm-hmm.
So you don't have to waste time and resources recomputing them over and over again.
It's like having a hidden arsenal of moves ready to go at a moment's notice.
That's a great way to put it.
Right.
Yeah. And that's where the cache and persist functions come into play.
Okay.
Think of cache as your basic power slam, dependable and effective. But persist is more like your signature move, giving you finer control over how and where the data is stored.
So cache is the go-to for most situations, while persist lets you customize your approach based on the specific match.
Exactly. Cache works great with RDDs and data frames using sensible default storage levels. Persist gives you the freedom to choose whether to go for a high-risk, high-reward move or a more grounded approach.
Now let's talk about how Spark handles all this data storage. It's got to manage resources for both processing and caching, right?
Right? Spark's memory management is like a skilled referee, making sure everything runs smoothly. It divides the available memory into execution memory for processing tasks and storage memory for caching.
Okay, so if caching isn't a major player, processing gets more resources.
Yeah,
And if you need to cache a ton of data, Spark can make room for it. It's
Uh-huh.
incredibly flexible.
precisely. And to take your caching strategy even further, you need to choose the right storage level. It's like picking the right move for the right opponent.
It's all about choosing the right wrestling move for the situation.
Yes.
Do you go for a high-flying, memory-intensive slam
Mm-hmm.
or a more grounded, serialized grapple?
Yeah.
Maybe you need a tag team combo with disk backup.
It all depends.
Hmm.
Yeah. Let me break down these storage levels for you. Memory only is the fastest option storing data in memory as deserialized objects.
Okay.
But if you run out of memory, you'll need to recompute those uncached partitions, which can slow things down.
So it's a risky move that could backfire if you're not careful.
Right. Then we have Memory Analyzer, which uses serialization to conserve memory.
Okay.
It's a bit slower due to the serialization overhead, but it's more memory efficient, a more calculated move
Right.
for greater control.
Okay, what about memory and disk? That sounds like a good balance.
It is.
Hey.
It tries to keep everything in memory for speed, but spills data to disk if it overflows.
Oh, okay.
It's a smart backup plan if your initial attack doesn't quite connect.
And lastly, we have memory and diskser, which combines serialization with disk spillage.
Yes. The most memory efficient, but also the one with the highest CPU overhead.
Okay.
Correct. It's a complex move that takes more effort, but can be very effective when used correctly.
So we've got a whole arsenal of storage levels to choose from.
Right.
But remember, caching isn't always the answer.
Yeah.
Don't cache data that's only used once.
No.
It's like warming up a wrestler who never gets in the ring. And be wary of memory monsters.
Yes.
Caching huge data sets without enough resources is a recipe for disaster. You need to know your limits and choose your caching strategy wisely.
Couldn't have said it better myself.
All right, so
Yeah.
I think we've covered a lot about the basics
Yeah.
of checkpointing and caching.
We have.
I think we've done a pretty good job of explaining
think so.
how they're different
Yeah.
and when to use them.
Yeah.
But there's a lot more to this.
Yeah, there is.
There are a lot more advanced things that we can dive into,
Yeah.
like how to optimize our caching and checkpointing strategies and all
Yeah.
that. So
Yeah, we'll come back to that
we'll come back.
for part 2
Yeah,
to talk about that.
absolutely.
All right, so I guess we'll see you then.
I guess we'll see you then. Welcome back to our deep dive into PriceSpark performance. By now, you're probably starting to see how caching and checkpointing are like having a championship caliber coaching staff
Right?
guiding you to victory in the data wrestling arena. Absolutely. But like any seasoned coach will tell you, there's always room for improvement.
Right.
So let's explore some advanced techniques that can really take your game to the next level.
Okay, one area where you can fine-tune your performance is cache partitioning.
Okay.
Remember, Spark divides your data into partitions.
Mm-hmm.
Think of it like weight classes in wrestling.
Right.
You want each wrestler competing against opponents of similar size and skill.
Yeah, you don't want to have like,
Exactly.
a flyweight going up against a heavyweight.
Right. If your partitions are too large, you might end up with some executors overwhelmed while others are just sitting around.
Yeah,
And if they're too small, you'll have a lot of overhead from managing all those tiny pieces.
makes sense.
It's about finding that sweet spot, the right balance between partition size and the number of partitions. Understanding your data and transformations is key here.
So if I'm doing a lot of filtering or aggregation, it might make sense to repartition my data before patching to make sure similar data points end up together.
That's a great strategy. Now let's talk about fault tolerance.
Okay.
We've already seen how checkpointing acts like a safety net,
Right.
saving your data to a reliable storage system.
Yeah.
But caching also plays a role here, even if it's a bit more subtle.
Really? I thought caching was all about speed.
Speed is a big part of it.
Right.
But remember that Spark keeps track of the lineage of your transformations.
Right.
Even if a cached partition is lost, let's say due to a node failure, Spark can reconstruct it from its lineage.
Oh, so it's like having a backup wrestler ready to jump in if one of your main players goes down.
Exactly. The show must go on. And to make things even more resilient, some storage levels offer replication,
Oh.
meaning multiple copies of each partition are stored on different nodes.
So it's like having a tag team partner ready to step in at a moment's notice.
That's right. You're prepared for anything. Now here's where things get really interesting. Caching can actually influence how Spark plans and executes your jobs.
Hold on, I thought caching was just about data access.
It is. But when a data frame or RDD is cached, Spark knows exactly where that data is. This allows it to schedule tasks that need that data on the nodes where it's already cached.
So instead of transferring data all over the cluster, it's like having your wrestlers train in their home gyms much more efficient.
Much more efficient.
Yeah.
This can significantly reduce data shuffling, which is one of the most time-consuming operations in Spark.
Yeah.
It's like minimizing travel time for your wrestlers, keeping them focused and energized.
Makes sense. Before we move on, I want to clarify something. The difference between broadcast variables and cached data frames. They both involve sharing data, but they seem to have different purposes.
Great point. Think of broadcast variables as a shared playbook
Okay.
that all your wrestlers can access instantly.
Okay.
They're perfect for small read-only data sets that need to be available to every task.
Like the rules of the match or a scouting report on the opponents, everyone needs to be on the same page.
Exactly. Cached data frames, on the other hand, are more like specialized training equipment that's spread across different gyms. Each wrestler only needs access to the equipment that's relevant to their training.
Got it. So broadcast variables are for data that everyone needs, while caching is for data that's used selectively by different parts of your application.
Now let's talk about caching in the context of Spark SQL.
Okay.
We've mostly focused on data frames and RDDs,
Right.
but caching is just as important when you're working with SQL queries.
Right, because the results of those queries can be pretty hefty.
Exactly.
Yeah.
The results of your Spark SQL queries can be cached just like any other data frame, using those familiar cache and persist functions.
So if I have a complex query that's used over and over again caching, the results can save a lot of time.
Absolutely. And Spark SQL even provides a specific command for caching, cache table.
Oh, okay.
This gives you even more control over how tables or query results are cached, with options for storage levels and lazy caching.
Lazy caching, what's that all about?
It means the data is only cached when it's actually needed. Think of it as having a backup wrestler on standby, ready to go, but not taking up space unless they're called in.
Smart. So are those temporary views that Spark SQL creates related to caching?
They can be. Spark SQL often creates temporary views for cached queries,
Okay.
which can help make your code more organized and readable.
Like giving each wrestler a nickname that reflects their style makes it easier to follow the action.
Now let's dive into some trickier situations
Okay.
that might require some more specialized caching strategies.
Okay.
One common challenge is dealing with data that has a very uneven distribution, what we call skewed data.
Skewed data sounds like trouble.
It can be.
Yeah.
It means some values occur way more frequently than others.
Oh, okay.
For example, in a data set of customer transactions, you might have a few customers who make tons of purchases while most only make a handful.
Ah, so it's like having a few dominant champions in the wrestling world while most are still trying to climb the ranks.
Exactly. And when you're caching skewed data, you need to be careful. A simple partitioning strategy could result in some partitions being much larger than others.
So it's like cramming all the heavyweights into one weight class while the others are practically empty.
That can lead to performance bottlenecks.
Yeah.
To handle this, you might need to use more advanced partitioning techniques like salting or range partitioning.
Salting and range partitioning. Those sound like some serious wrestling moves.
They are. Salting involves adding a random value to each data point before partitioning, which helps to distribute things more evenly. Range partitioning is about dividing the data based on specific value ranges, which works well if you know the distribution of your data beforehand.
So it's all about using the right techniques to make sure your cached data is well organized and easily accessible.
We've covered a lot of ground here,
Yeah, we have.
from the basics of cache and persist to the nuances of storage levels, file formats, compression, and advanced partitioning techniques.
It's clear that caching can dramatically improve the performance of our Spark applications.
Absolutely. But it's not a magic solution. It's a powerful tool that needs to be used strategically and with a good understanding of your data and your Spark environment.
Welcome back to the deep dive. We've been training hard in the PySpark gym. Learning the moves of checkpointing and caching.
Yeah.
Now let's step into the real world arena and see how these techniques play out in a real match.
Okay. Let's say you're analyzing a massive data set of customer transactions, looking for patterns and insights to help your business make, championship-winning decisions.
The kind of data that can really give you an edge.
Exactly. You've got data streaming from all directions, and you need to process it quickly and efficiently.
No time for slow, sluggish performance.
Right.
We need those insights in real time.
Your first task is to clean and prepare the data,
Okay.
filtering out invalid records, transforming some fields, and joining with other data sets.
So it's like getting your wrestlers in top shape and ready for the main event.
Exactly. And this is where caching can really make a difference. You can cache the results of each transformation, so you don't have to recompute them every time.
So it's like having those pre-match warm-ups and drills already done,
Right.
freeing up your wrestlers to focus on the match itself.
Next, you need to perform some aggregations,
Okay.
like calculating total sales by product category or identifying your most loyal customers.
The kind of insights that can inform your game plan.
Exactly. Caching comes in handy here as well. You can cache the results of those aggregations so you can quickly query them and generate reports without having to rerun those complex calculations.
It's like having those key stats and metrics at your fingertips ready to be analyzed and shared.
Now imagine you're bringing in a machine learning model
Okay.
to predict customer churn or recommend products.
Ooh, that's next level strategy.
Right.
Using data to anticipate your opponent's moves.
Exactly. Machine learning often involves iterative algorithms that process the data multiple times,
Right.
like a wrestler practicing the same moves over and over to perfect it.
Yeah, but without checkpointing, those repetitions can lead to a tangled mess.
Okay.
Slowing down your training and making it more prone to errors.
It's like your wrestler getting bogged down in unnecessary drills, losing focus and stamina.
So checkpointing comes in to save the day.
Checkpointing allows you to save your progress periodically, keeping things clean and ensuring you can recover quickly from any setbacks.
It's like giving your wrestler those crucial rest breaks, allowing them to come back stronger and more focused.
Now let's say you're taking your PySpark application to the big leagues, a production environment.
Ooh, where the stakes are high and performance is critical.
You need to be sure your application is resilient and can handle any unexpected events.
Like a champion who can take a punch and keep fighting.
This is where reliable checkpointing is essential. Saving your data to a robust storage system like HDFS or S3 guarantees that your application can bounce back from any disruptions.
It's like having a backup plan in case your star player gets injured. The show must go on.
And to take your performance to the next level in production, you might want to consider more advanced caching techniques, like cache partitioning or tiered storage.
Cache partitioning and tiered storage, those sound like expert-level strategies.
They are. Cache partitioning helps distribute your cache data more evenly across the cluster, while tiered storage combines different storage levels for a balance of speed and cost-effectiveness.
It's like having a well-coordinated team, each member playing their part to achieve peak performance.
As you can see, checkpointing and caching are not just theoretical concepts.
Right.
They're essential tools for building real-world PySpark applications that are fast, reliable, and ready to take on any challenge.
They're the cornerstones of a championship-caliber data processing strategy.
Exactly. The more you work with these techniques, the better you'll become at optimizing your Spark jobs for peak performance.
We've covered a lot of ground in this deep dive, exploring the power of checkpointing and caching, along with file formats, compression best practices, and real-world applications.
We've seen how these techniques can boost your Spark skills, empowering you to process data with the speed, efficiency, and resilience of a true champion.
And remember, this is just the beginning. The world of PySpark is constantly evolving with new tools and techniques emerging all the time. Right. So keep exploring, keep experimenting, and never stop learning.
That's right. In the data wrestling arena, the key to success is to stay agile, adaptable, and always ready to face new challenges.
Armed with the knowledge and skills from this deep dive, you're well equipped to tackle any data challenge that comes your way.
So go forth and conquer those data sets. Until next time, keep those Spark jobs running like champions.
That's all for this episode of The Deep Dive. Thanks for joining us.